topic, but it is an important fact to know to understand what's going on within a simplex. If you think about the pivoting operation that we do to go from dictionary to dictionary, at the end of the day, all the dictionaries is really a restatement of the problem. You're really doing nothing except that you're rewriting the problem again and again and again in different ways. And you'll see that this will give you an idea why that's the case. Let me first of all give you some idea about what I'm going to say. Before I tell you anything in general, let me demonstrate what I'm going to say in general with an example. Again, going back to the same boring example that I started from the very first day, you're trying to maximize the function z, which is 3x1 plus 5x2. By the way, your exam will not be going over this topic because your exam will go over everything that we did till last time. So you have this maximizing problem where the constraints are given, and I wrote down the corresponding slack form. So for each of the functional constraints, you have a slack variable. So the slack variables are x3, x4, x5. x1, x2 are the decision variables. Now here's the question that I'm asking. Given that, for this example, we looked at all the dictionaries, right? For this problem, we looked at the simplex method. We went from one dictionary to another dictionary and so on. Now, I am trying to now ask, I'm trying to sort of ask a different opposite question. That is, suppose that I tell you that one of the dictionaries in simplex had a basis x2, x3, x5. So whatever, at some point during the simplex, the basis set consisted of x2, x3, x5. Can you come up with that dictionary without starting from the beginning? What do? We start with the dictionary, initial dictionary, and then we apply pivoting, go over a bunch of dictionary to get to the final dictionary, right? Now I'm saying, suppose at one point during simplex, the basis set was x2, x3, x5. Can you tell me what was the dictionary? What was the dictionary without going through simplex? Am I making sense? Is the question clear to you? All right, so let's see how we could do it. So first of all, I'm looking at the slack form and I'm rewriting the slack form. Basically what I'm doing is that I'm going to think of each equation as an equation in 5 variables. So I'm going to put 0 coefficients for the variables that don't appear in one of the equations. So the slack form that I have here, okay, I am going to, do you need a second to write that down, slack form? Okay, I'm going to replace that with this here. This is the same as the slack form, except that I wrote down all the variables. So I put 0 coefficients for the variables that don't appear in any of these equations. So each one of them, I'm thinking of them as an equation in 5 variables. Now, anytime I have a system of linear equations, I can express it in terms of matrix equations, right? So what's the coefficient matrix? How do you write down the coefficient matrix? You guys remember linear algebra? So I get 1, 0, 3, right? 1, 0, 3. The coefficients of x2 will be 0, 2, 2, 0, 2, 2. The coefficients of x3, 1, 0, 0, 1, 0, 0. The coefficients of x4, the coefficients of x5. Right? And then that will be multiplied by the vector of the variables. And that's equals to the right hand side 4, 12, and 18. Am I making sense? So that's the coefficient matrix. That's the matrix form of the linear system. Now I'm going to do something really, really odd, but I'm pretty sure it's going to make sense to you. What I'm going to do is that, remember what I said about, I know what my basis is, right? If I know my basis, do I know my co-basic variables? So if my basic variables are x2, x3, x5, what are the non-basic variables? Well, whichever are missing, right? x1 and x4. So what I'm going to do is I'm going to look at my coefficient matrix A. I label the coefficient matrix A, and from there I am going to take the columns corresponding to the basic variables. So which columns correspond to the basic variables? Well, notice that the basic variables are x2, x3, x5. So I'm going to take column number 2, 3, and 5. Okay? I'm going to form a matrix I'm going to call AB, B for basic. AB consists of columns of A corresponding to the basic variables. Is that clear? AB consists of columns of A corresponding to the basic variables. And what is AI? AI consists of the remaining columns which correspond to what? The non-basic variables, x1 and x4. So I can rewrite this equation as AB multiplied by the vector of basic variables plus AI multiplied by the vector of non-basic variables. You might say, how do I know that that's the case? Well, it's going to work out that way. It always does. Am I making sense? But what is important is that the variables that I took here, right? The columns here corresponds to the variables here. The order is important. I cannot write x2 here and x3 here, right? Because this is the column. The first column is for x2, second column for x3, third one for x5. So you have to write your variables here in the same order. Okay, that's the important thing. But these two equations are equivalent. If you explicitly write down the equations on the left side of this second equation and the left side of the first equation here, you'll see that we get the same equations. Is everybody okay? Now, why did I write it this way? Notice that, remember what I wanted to do? I wanted to write down the dictionary, right? What does the dictionary mean? Dictionary means that you are going to solve for x2, x3, x5, right? That's basic variable. You solve for the basic variables. Notice that from this equation, can I solve for my basic variables? Can you solve for your basic variables? How would you solve for the basic variables? Well, from the right-hand side, you're going to subtract this, and then you can multiply both sides by the inverse of AB, right? Is this clear? So, subtract AI times x1, x4 from the right-hand side. That's what I did here. And then I multiplied both sides by the inverse of AB. Right? By the inverse of AB. And that solves for x2, x3, x4, x5. Am I making sense? So what are you going to end up with on the right-hand side? On the right-hand side, you're going to get expressions involving x1 and x4, right? Is it right? On the right-hand side, when you multiply out everything on the right-hand side, you get expressions involving x1. You get a constant plus something times x1 plus something times x4. Okay, you're going to get three of those expressions on the right-hand side. So my point is, this is actually our dictionary. The only thing that I'm missing is I didn't write down what z should be in the dictionary, right? Am I making sense? So how do I write down z then? So if you multiply out everything on the right-hand side, you're going to get what? A 3 by 1 matrix, right? If you look at the dimensions on the right-hand side, you'll notice that at the end you're going to get a 3 by 1 matrix. And the 3 by 1 matrix that you get is this one: 4 minus x1 plus 0 x4, 6 plus 0 x1 minus half x4, and so on. So you solve for x2, x3, x5 in terms of x1 and x4 in this way. And now it's clear that from this I can write down the dictionary. Right? x2, I wrote x2 after x3. So x2 is the same as the first row, x3 is the same as the second, x5 is the same as the third row here, right? So that's my dictionary, except that I need to know what is z. How would I write what should be the z value in the expression, in the dictionary? How do I get z? Well, originally z is what? Z is 3x1 plus 5x2. That's the original z. What you have to do is that on the right hand side here, because x2 is a basic variable, you can replace x2 by the right hand side. Right? So you can replace x2 by 4 minus x1 plus 0 x4 here. If you do that, you can express z. You can express z in terms of x1 and x4 as well. Am I clear? Look at the original definition of z. Wherever in the definition of z, wherever you have a basic variable, replace that by the right hand side for that variable. You can express. So then you can express z in terms of x1 and x4 in this way. So I get the dictionary. Pretty simple, isn't it? So given a basic set, given a basis, I can always come up with the exact dictionary associated with that basis. Am I making sense? There is a little bit of caveat here that I was gonna avoid, but let me say one thing here. When I looked at the inverse there, right? When I looked at the inverse, how did I know that the inverse exists? I didn't really tell you that, right? How do I know that whatever matrix you get there will have an inverse? Let me just say that knowing that the dictionary was obtained at some point during Simplex, you are guaranteed that the inverse is there. Whatever matrix AB you get, it is invertible if we know that the dictionary is a dictionary from the Simplex. Okay? So I'm not going to say any more than that, but and if you think about this, if you go back in your notes, you'll see that this was one of the dictionaries in Simplex when we carried out that problem. Is everybody clear? Any questions on that? Any questions at all? No? All right. So I'm just going to generalize this idea for the general problem. Okay. So let's let x1 through xn be decision variables. X plus 1 up to xn plus m be the slack variables. So remember our general standard form problem. How many constraints were we denoting? We were denoting the number of functional constraints by n, right? Number of decision variables by n. So I am denoting the slack variables by xn plus 1 up to xn plus m, and then the decisions are x1 through xn, and I'm going to call x to be the vector of all these variables. So x1 through xn and also xn plus 1 up to xn plus m. And then we are trying to maximize z. Z is c1 x1 plus ... cn xn. However, what I'm going to do though is that I am going to add some more terms here. So this is originally what z is, but I'm going to add cn plus 1 xn plus 1 plus ... plus cn plus m xn plus m. And What are these coefficients here? 0, right? So I'm basically adding 0 times each of the slack variables here, nothing else. Why am I doing that? Because I just want to speak about C. So I'm going to take C, the vector C transpose to be the vector of C1 Cn Cn plus m, and keep in mind that Cn plus 1 up to Cn plus m, they are 0. Okay? And if I do that, the reason I did that is because then I could say that Z is what? Z is C transpose times my big vector X. Is everybody okay? You guys are okay with that? I can say that Z is C transpose times X, where X is all the variables including decision and the slacks, and the vector C transpose is all the coefficients but zeros for the slack variables. Now, let's recall that the functional constraints, we denoted them by this, right? For the general problem, we used AIJs for the coefficients, right? So now I have all the variables. So for all the functional constraints are written in terms of all the variables. Okay. Now, can someone tell me what is the coefficient A1 n plus 1? What is this coefficient? What's the value of that? 1, right? Because original variables are this, right? So your equations were, your inequalities were these expressions less than b1, bi, bn, right? But now you're adding a slack to each one of the constraints, right? What would be the coefficient of a1 n plus 2? 0, right? So same thing here. When you come here, ai n plus 1 would be 0. Which coefficient here would be 1? I'm sorry? M plus I, yeah. And at the end, an n plus m, that would be the 1, and all the other coefficients of the slacks would be 0 here. So in each equation, all the coefficients of the slacks are 0 except for 1, right? You realize that? Which is not important at this point, but okay, now I'm going to look at the coefficient matrix, and so I can write down this linear system as a coefficient matrix times x equals to b. B is the right hand side. B is the vector of the right hand sides of the equations. Everybody's okay? Now let's say you are given a basis. So how many variables do I have in my basis? You guys remember? Number of basis vectors is the same as number of functional constraints, which is m. So I have the basis is, I'm denoting the basis variables by xb1 up to xbm. Now, some of the columns here, m columns here, will be corresponding to these variables, right? Whatever the basis variables are, some of the columns of A, there are m columns of A corresponding to the basis variables. So I'm going to call AB. AB is the matrix consisting of columns of A corresponding to the basic variables. And AI will be the remaining columns of A, and they will correspond to the non-basic variables. And I'm going to say xi is the vector of non-basic variables, and xb will be the vector of basic variables. Okay? Is everybody clear? So xb is what? xb1, xb2, xb3, xbm. Xi is the remaining non-basic variables. Then this equation that I have, this matrix equation that I have, I can rewrite it as ABXB plus AIXI equals to B. Just like we did in the example. So this matrix equation, I'm looking at the columns corresponding to xb, and so that those columns are AB, and then columns corresponding to xi would be AI, so I get AB xb plus AI xi is b. And from there I can easily solve for xb. So what is xb? xb would be b minus AI times xi and multiplied by AB inverse. Is everybody clear? Right? So once I have solved for xb, I get the dictionary, except for one thing. I need to know how to come up with z for the dictionary. So what would be z? Well, remember z. Z is C transpose X, right? What was that? This was C1 X1 plus dot 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 Cn Xn plus Cn plus 1 Xn plus 1 plus dot 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 Cn plus m Xn plus n. Right? What do you need to do to come up with z? Well, some of these variables are basic variables, right? Among the variables from x1 up to xn plus m, some of them are basic, right? Whichever are the basic, you can replace them by their value you obtained here. Am I making sense? So here xb is this. So here xb1, xb2, xbm, all of them are known from here. You're going to plug them in the z, okay, and you're going to come up with the value of z. In other words, I can rewrite this as CB transpose times XB plus CI transpose times XI, can't I? So I'm going to separate the basic variables and separate the non-basic variables. And I can write it in this way. And once I have this, then I can replace XB by the value that I got for XB. And remember, the value for XB is in terms of the XI's. So now I can say that, let me just say that this is equal to CB transpose multiplied with XB is AB inverse times B minus AI XI and then plus CI transpose XI. Right? So I can explicitly find what Z is in terms of the non-basics. I mean, you don't have to remember these formulas or anything. All I'm trying to say, you can express Z in terms of the non-basics in this way, and then at the end I can come up with the dictionary. So the dictionary would be whatever XB is, and then you have to write down what Z is. So let me just copy what Z is. Z is, you know what? When I write Z, I'm going to write the constant guy separately, and the constant here would be CB transpose AB inverse times B, and then you're going to get negative CB transpose AB inverse times AI plus let me do something here. Let me say let me say plus like this, and then I'm going to put parentheses here, minus plus CI transpose. The whole thing will be multiplied by XI. All I did is I looked at XI times whatever and XI times this guy, so I just factored out XI, and the constant would be B times this times this. Okay? Again, you don't have to remember this as formulas or anything, but the whole point is I can actually write down explicitly what Z is. Any questions? Does that make sense? Okay. All right, so I'm not going to speak any more today, but I just want to finish by what we are going to do next time. So far, we have when we have simplex, right? Simplex, we said that there are two phases of simplex. One is you have this initialization phase where you start with the dictionary. Let's say D0, and then you get to D1, you get to D2, and then you keep going, and at some point you get some dictionary DN, and all these dictionaries are not feasible, okay? So, and let's say at some point you get DN plus 1, and that's the first feasible dictionary. So first feasible dictionary, and then after that, we know that if you apply pivoting to a feasible dictionary, you always get a feasible dictionary. So after that, all the dictionaries are feasible, and until you get to the final, let me just say DF, the final dictionary. So this is known as the optimization phase. We talked about this before. And this is called the D0 up to DN. So you're doing some sort of pivoting. If remember how we wrote our first dictionary, and so far I always had examples where the first dictionary is always feasible, right? What if you don't start out with a feasible dictionary? So all these dictionaries are not feasible. Not feasible. So these are not feasible dictionaries. And this is called the initialization phase. Initialization phase. Okay, so far we spoke about only the optimization phase, how Simplex carries out pivoting and goes from one dictionary to another. We also looked at what's going on geometrically, right? Simplex goes from one vertex to the next, adjacent vertex, and so on, until you get to the final dictionary. And we looked at what phenomenon like cycling that can happen, and so on. But we haven't said anything about the initialization phase, and that will be our next topic. Okay, so in initialization phase, what happens is that when you make your first initial dictionary, it's not going to be feasible. Okay. Then the question is, so for example, let me give you an example. Let's say you have, let me make a region here. So let's say you have a region that looks like the following. I'm just arbitrarily making something, okay? So let's say these are the vertices that I have. So let's say whatever your feasible region is defined by this region. Okay? If you write down your initial dictionary the way that we did, okay, your initial dictionary, the solution will be this point. which is not a feasible point. Remember what we do when we create our first dictionary? What are the basic variables? The slacks are the basic variables for the first dictionary, and the decision variables become the non-basic, right? So they are 0, all of them. So that would mean that 0, 0 will be your solution for the first dictionary, right? Is that feasible? No, it's outside the feasible region. So that's what I mean. Your first dictionary will be a non-feasible dictionary. Okay? The question is then, the simplex remember, simplex goes from vertex to vertex. So the simplex must do something to take this point and move to one of these points, right? You can either move here, or move here to one of the vertices. So how do you move from the non-feasible initial solution to one of the vertices, okay? And see that the initialization phase simply does that. Okay, you're going to start with a non-feasible dictionary, and then you have to do some pivoting operations, just like the pivoting operations for initialization phase is actually very, very similar to the pivoting operation in the optimization phase. There are some differences, and it's not a huge difference, but there are some differences. But there is some tricks that we have to do to begin with. Is that making sense? So I'm not going to say any more than that today. The reason is when I start that, I want to finish it. Okay. All right. So I will keep in mind that I'm going to send you the